Hey guys, well here we are in chapter 6.5, properties of logs. And these are properties, you're going to see that they're very similar to properties of exponents. So I'm going to draw analogies here because we know exponents and logs can be written in either, right? They're both pretty much the same. You can just rewrite a log as an exponent as a log. So they follow the same properties. So let's take a look here. I know the equivalent exponent property would be something like this. I know that x squared times x to the third means I'm going to add the exponents, right? And it also means I can say x to the fifth equals x squared times x to the third, right? I can go back and forth. Well, it's the same thing here. If I have a product, a log of a product, I can separate it by a plus. Quotient property of exponents says when I divide with exponents, I'm actually subtracting them. Right? Same thing here. If I have a log of a quotient, I can write it as a difference. Now the power property, this is kind of interesting. If I'm taking a log of something with an exponent, it's okay to stay in the exponent, but also another legitimate place for it is in front as a coefficient. So let's use these properties. Back in the olden days, there were no calculators with logs, and we had to use a table. So in your calculator, there are two buttons that have logs. One just says log, and that assumes a base of 10. And the other button says ln, and that assumes a base of e. So what do we do in situations where the base isn't 10 or e? Well, imagine if we are given two pieces of information. We're given that log base 2 of 5 is equal to 2.322, and log base 2 of 12 equals 3.585. So how can we find log base 2 of 60? They didn't tell us log base 2 of 60. But I can notice, if I split this into log base 2 of 12 times 5, right, that I can use my power property here, product property, and I can separate it into log base 2 of 12 plus log base 2 of 5, right? And log base 2 of 12, we know, is 3.585, and this is 2.322, which gets you to 5.91. Okay, again, we're looking for 5s and 12s because that's what we've got here. This is a quotient. But I don't have log base 2 of 25, but I could notice that 25 is 5 squared. Right, so this is my quotient property. So I can say that's log base 2, 12, minus log base 2 of 5 squared, right? And we know from our power property here that we can move the 2 into the front as well. So I can say log base 2 of 12 minus 2 times log base 2 of 5. All right, now I have enough information to substitute in the 3.585 here, and the 2.322 here. And that is going to get me negative 1.06. Okay guys, our last one. Well, I know I got to deal with 5s and 12s. So what I did first is I said, well, let's do 720 divided by 5. And I got that it was 5 times 144. And then I said, I know that 144 is 12 squared. So again, I can use my product property, and I can split that into log base 2 of 5 plus log base 2 of 12 squared. And then that 2 can go in the front. So I can say log base 2 of 5 plus 2 times log base 2 of 12. Right? And now I have my pieces in here. And I get, with that, I end up getting 9.49. Right, so using the product property, quotient property, and power property, I can break these logs up into pieces. Okay. Notice none of these had variables in them. But guess what? I can also do the same thing if there are variables. Right, now here it says expand the logarithm, but I want you guys to add simplify if possible. Because sometimes you can evaluate the log, like we did 2 sections ago. If I end up getting a rational number when I try to evaluate the log, I'm going to simplify it. If not, if it's an irrational number, I'm just going to leave it. Just like I don't reduce a fraction 9 over 41, right? I leave it as 9 over 41, but I would reduce the fraction 2 over 4. So these can be a little bit difficult to decipher here. We want to remember that if I have log 10x, there's a 10 here we don't write it, but it's there. And that 10x means 10 times x. So I can actually split this into log, and I'm going to write the 10. Okay, and so now clearly I can't simplify something that has an x in it, but could I simplify this? This is saying 10 to what power equals 10? Well, here it's 1, right guys? So I can say it's 1, and then I can bring this down and say plus log base 10 of x, and I don't even really need the 10. I can just say it's 1 plus log x. Okay, here we've got ln 2x to the 6. Again, there's a multiply there. So I can separate this into ln 2 plus ln x to the 6th. Now this is a custom here. When you're separating logs like this, you'll almost always see if there's an exponent that it's going to be in front. It's not wrong if you leave it like this. It's just you're going to be most likely to see the 6 in the front. So I'm not here. If I try to simplify this, is this simplifiable? Well, ln means log with a base of e. So can I find a value of x that's rational? E to the what equals 2? Nah, that's really going to be a yucky irrational number. So this is not simplifiable, right? Because it would end up being a decimal irrational number. Okay, here we've got product and quotient mixed together. So if I have something on the top, it's going to be a positive log. And if it's on the bottom, I'm going to have a minus log. Now that may be hard to conceptualize until I show you. So I'm going to write log base 3. Okay, so on the top I've got x to the 4th. So that's a positive log. The 3 is on the bottom. And the y to the 3rd is on the bottom. So I have to remember to separate out the 3 and the y to the 3rd. So again, I'm going to put that 4 in front. This is saying 3 to what power equals 3? Well, that's rational, that's 1. So I can put a 1 right in here. The value of log base 3 of 3 is 1. And then with this, I'm going to move the 3 in front. And I'm done. So here is just like what we did here. We used our properties, power property, quotient quotient property and product property to separate out a single log into a sum and difference. I can also go backwards, right? I can also take sums and differences of logs and squish them together into a single log. So when I see a plus, this is the thing that's it's hard to not say that's log base 2 of 11. But this is our product property. So what we're going to do here is we're going to say log base 2 of 3 times 8, which is log base 2 of 24, right? And I'm not going to simplify that, because 2 to the what equals 24. That's not rational. Right? If I can't just figure it out with a rational number, then I'm just going to leave it. Okay, guys, here, if I'm going to use my quotient property here, but they both have to be plain old logs. So I want to move that right? I want to move that up to the top there. So we know that log base 5 of 4, and that, right, log base 5, and this is 5 squared, which is 25. Now some of you might be going, oh wait, I can simplify that. But remember, our goal is to condense it to a single log. So our goal actually is not to simplify it. So that is what we end up with, right? Because that minus means it's the quotient property. Okay, guys, here we're going to move that 3 up, and here's the thing that we have to be careful about. When I move the 3 up to the exponent, it has to be the entire 6x that is raised to the third. That means the 6 has to be raised to the third as well. So this would be ln 216x cubed, right? And this is going to be our product property. So I'll have ln 216x cubed times 4y. And then 216 times 4 is 864. That is what I end up with as a single log. Okay, this one, right, is I'm going to have a sum and a difference here. So I'm going to be using both my properties. Notice this is positive, so this log, this 625 is going to go on the top. This one's going to go on the bottom because of the minus. And this one's going to go on the top. But before that, I have to deal with this 1/3. I have to bring that up here, right? And I have to say log base 2 of 27 to the 1/3. Well, 27 to the 1/3 is 3. So what I've got here now is log base 2, 625 minus log base 2, 125 plus log base 2 of 3. So I want a single log. So I'm going to do this. The 625 goes on top. The 125, because it's a minus, goes on the bottom. And the 3, because it's positive, goes on top. And that ends up being, if I reduce this, I get log base 2 of 15. Okay, so we were talking about how your calculator does a base of 10 and a base of e. So if I want to use my calculator and I have a log that's not a base of 10 or a base of e, I want to change it to a base of 10 or a base of e. So let's say I have a log that has a different base, base c. Well, I can change the base to anything I want, right? Any base, b. But what I usually want to do is I want to change it to a base of 10 or a base of e, because that's what my calculator will do. So here, I can use either log or ln. I'm going to get the same answer. If I look at this here, this is c and this is a, right guys? So what I can do in my calculator is I can say log 17. And now here's the thing, guys. Make sure when you push the log button, it's going to give you an open parentheses. Make sure you close the parentheses before you divide. Because otherwise it's going to do 17 thirds. Right? And if I do that, we know that's going to be a decimal. If I do that, I get 2.58 approximately. Okay, guys, cool beauty of math moment. Do the same thing with ln. If you do the same thing with ln, you're going to get the same exact value. It doesn't matter which you use, ln or log. You're still going to get the same value. Okay, guys, so let's do this one. Here I've got C and I've got A. So I can just say log 294, remember, close parentheses, over log 9. And that ends up being 2.59. That's just by chance that they're so close. And then the last one, oops, sorry, this should say 4/9. Here I've got C and here I've got A. So I can say log 4 divided by 9 in parentheses over log 7. And that is going to give me approximately -0.42. Okay, guys, I will be back with video 2, which is going to have our word problems.